Okay, so we're talking about direct variation as an nth power.
Yeah, I got 3.
All these statements are equivalent.
What does n represent?
There's not one
A power.
difference.
Yeah,
So this
n
would be
is
like,
any power.
so you could say that A varies directly as a power of R.
Okay, yeah.
And what's the y in the area formula? What's k?
Pi,
What is x?
r, the range.
And what is n?
2 or power 2.
Oops, sorry. And it's 2. Yeah. It's not more complicated than that. So let's do an example.
I love examples.
Who's in what level of science?
Chemistry.
I'm in chemistry.
Who's in physics?
Honors.
Who's in physics?
Yeah, I live in
I used to be in physics.
Did you talk about inclined planes?
Yes.
Good.
Yeah, I'm sorry.
You. We got now. Chem. But at Westtown, physics was like sophomores. Got it. That just freshman calendar. Really? Physics for freshmen? I feel like bio should go back to being freshman. My freshman year, I took Earth and Environmental Science honors.
Holy smokes. How impressive.
Really on another level. She's like in love with her Spanish class. Even though like she's like, wow, you guys are so silly, and it was like our least silliest day.
Stop.
Oh. Look that way.
So here's our physical setup. Here's our inclined plane. And here's t equals 0 seconds.
I hate these.
Why?
Here's
I know
t
it's
equals
like
1 second. And then here's t equals 3 seconds. And this is something like, this is feet. So part A, write an equation.
I think so.
Relating the distance.
Wait, T equals what?
Okay.
T equals 0 seconds, t equals 1 second, t equals 3 seconds. Write an equation relating the distance traveled to time. Part B,
Why is the 10, 20, 30, 40, 50?
that's measuring distance. So in the first second, the ball rolls 8 feet.
Basketball. It's a basketball.
So how far does the ball roll during the first 3 seconds?
I don't like all that whispering happening.
So we know that we're gonna use which form of proportionality are we going to use based on the wording of the question?
I know.
What do you know?
Direct variation as an nth power.
Yeah, so the question kind of gives that to us right straight away. So it's direct variation or directly proportional, synonymous to some power, the square of the time. So we would like something of the form y equals k x to the n. So what can we get out of this equation? What do we have so far?
Well, is v the y?
Yeah, theta is y. So let's call let's say let
Would be 8.
d
When you just
be
do 8 times 3.
the distance. No, because it's not directly proportional. It's directly proportional to a power
So, x is time because it's
in feet.
Yes.
and so it has to be the n.
So what else can we do? So we've got d so far. What else do we need? What else? What do we have? So what do we have in
X
place?
is time.
X is time.
In
Because
seconds.
it's squared.
Let d be time in seconds. What's my power?
2.
It's 2. And
Why is it 2?
Because it's squared. Because it's square.
Okay, yeah, I see.
and it's time. It's t because it's time because they told us it's the square of the time. So we almost have our equation of proportionality. What are we missing?
K.
So we haven't come up with a k yet. That's fine.
Can you
So-
solve for k?
We're gonna solve for k. How do we solve for k?
Plug in 8 and then
So 8 in place of distance.
8 equals k 1t, like 1 squared because it's the first second.
So it's 1 second squared. So that implies that k is what?
8.
Amelia? Solve for k. Solve for k.
I don't know.
Are you asking like what we're doing next?
No, what? Solve for k.
Eight.
No, it's 7.
That's 8.
8. What? No.
This is k times 1 squared. 1 squared is 1.
It's
Yeah.
8. Oh
But
my
then you-
goodness,
Okay,
guys.
sorry.
Come on.
Okay, it's 8. Sorry, I was minusing by the side, not dividing. And so k divided by 1 and it's 8.
Right, k is 8.
Hey, Eric.
All right. So the equation relating distance to time is what?
Uh,
Bro,
what
is
do you
it?
mean? What do you just plug it back in and it would be
Yep,
8?
we've solved for 8. We've solved for k. So let's plug it into our equation for time.
8 or yeah, 8 equals.
Not 8. 8 is k is over here.
Okay, so are you asking like d equals
Yeah.
8 t squared?
D equals 8 t squared is our equation for distance. So we've written an equation. That's it for part A. Now part B is asking for what?
How
First 3
far?
seconds.
Distance in 3 seconds.
Right.
So you can just.
So this is an equation in terms of t. So D is an equation in terms of t,
T equal to 3.
and we're going to evaluate at t equals 3. So how do I do that?
Just
8,
8 times
multiple
t times
9.
3 squared.
6.
That is a fast ball.
That's what I said. I said that.
I know.
So what is
I
D?
was remarking that it was right.
What's D?
72.
72. I disagree.
Oh no.
Wait, say hey to
Right.
Game.
Yes.
So the ball rolls 72 feet in the first 3 seconds.
From war.
I'm sorry, Carlo.
It's okay. We were just wondering.
How are B and
What?
oh,
Well, what?
I read it wrong.
Inverse variation.
So wait, so
Wait, where
K
did you get 9?
K is always gonna
Three
be
squared.
3 squared.
K is always gonna be 8 in this equation.
Yeah.
Yeah.
Not, I thought you meant like in the grand scheme. of
And right, I agree. It's not a universal constant, but we can get that by this data point. We know that if it travels 8 feet in 1 second, then the time is going to vary, the distance is going to vary, but we were able to extract a value for k out of just one data point. And then we can use that to construct a complete equation of proportionality. And then we can use that to say how far would it go after 25 seconds or after
Yeah.
300 seconds.
That edge is so straight.
Thanks, Carlo.
Mm-hmm. If I was a straight edge, I'd be curvy.
Thanks, Carlo.
Yeah. Curvy edge.
Okay, we're going on to we've had direct variation as an nth power, and now we're going to talk about inverse variation. So based on everything we've done before, what are my equivalent statements for inverse variation?
Indirectly. Or inversely.
Inversely.
Why is it inverse and not indirect?
Indirectly would be like random chaos.
Oh.
Inversely means something very specific in math. So what's my second equivalent statement?
Why is inversely proportional with x?
Yeah.
Carlo agrees. What formula am I going to use for y varies inversely as x with some constant k involved?
Negative y to the negative 1.
So it's not an additive inverse. It's a different kind of inverse.
Don't know. So, we'll butcher down. We'll butcher down, right, Eric? Right, Eric? Okay.
不要忘了. So where's my k gonna go?
K equals
No, y equals.
y
equals k.
y equals x times k to the n.
No, that's the other thing. That's the varies as an nth power of x.
Yeah.
This is y varies inversely as x.
Is it just xk?
No, that's direct proportion. Y equals kx is directly proportional.
Y
And
equal-
they
y
switched
equals
it 'cause of
K
inverse.
k over x.
Oh my goodness.
Oh.
Was that real? Did I just do that?
Yeah, you did it.
Hey, good job, Carlo.
I'm feeling it now. I'm hot.
And then just for free, if x and y are related by y equals k over x to the n, then you would say y varies What?
Inverse.
Inversely.
To as x to the nth power.
What the hell?
Or y is inversely proportional to the nth power of x. Yeah. So we've got a bunch of different variations here. We've got direct variation. We've got direct variation as the nth power. We've got inverse variation, and we've got inverse variation as the nth power. So we've got 3 models.
That's 4.
We've got 4. I just circled 3 things and said 4 things and said 3. That's not great. I'm a math teacher.
Please.
Yeah.
Wait.
Mr. Shino, can you scroll up a little bit?
Yeah.
please?
No.
Mr. Kayla, you should change your clock to normal time.
I really shouldn't.
Why?
It's 2:36.
No, I know, it's just, I don't like it.
It stretches your mind.
Yeah, Kira.
You should constantly be pushing your comfort zone.
No, I just don't like it. Like, I don't like that.
like it.
Like, it should be, like,
If
it's
you're
not-
normal, I don't like it.
Yeah. No, that's true, that's true.
Do you-
Carl, I agree with you.
Yeah,
I agree.
yeah.
Why did I go through like 2 pages today already? Or, that's only
I'll show you.
You're losing it.
I am losing it. I have so much homework for you.
Not enough.
No, too much.
How much?
Like 1 for every single
Oh
classes.
my
At least
goodness.
something. Which I take most of.
Ooh.
Oh my lord. Slow down, you crazy child.
He's a man.
Isn't that a song? That's Harp song.
Okay, so with the direct variations, there's 4 different equations that we could use.
With
No.
variation in
Oh,
general.
there's 4 different kinds of variations.
4 different kinds of
So
variation.
one is direct, one is inverse, and we have 2 more to learn.
So which one are we going to do now?
It's to the nth power. It's like it's direct, inverse, or yeah, direct.
We're doing inverse
direct
right
to
now.
the nth.
For this example, which one are we going to do?
Inverse.
So what's my equation of
It's not y. It's
proportion-
Y equals K over X.
oh sorry,
Thanks, buddy.
y equals k over x. By the way, I would say we only have 2 equations.
So we won't use the other 2 and like.
I would say we only have 2
And
because
one's just
when
variation.
n equals 1,
Oh yeah. Okay.
that's the same equation. When n equals 1, that's the same equation. That's a special case of inverse variation, and n is just equal to 1. This is a special case of, this is a special case of direct variation when n equals 1. So we only have direct and inverse.
Let's scroll back to the.
Okay.
So first I'm going to name my variables. So I'm going to say let P be the price.
Demand?
Yeah, that's the man.
Which one? Here?
Yeah. No. Yeah. Okay.
This one too?
No, I got it.
Are there ever gonna actually be like problems written that like it gives you like varies inversely? Like is it actually written like that?
I mean, we're doing one right now.
Okay.
So we're going to say let P be the price and let X be the demand. And we know that which equation of variation do we need to use?
Inversely.
Yeah, inversely. And it's not the square of the price or the cube of the price or the square root of the price. It's just the price. So we're going to assume that n equals 1. Kira?
You didn't finish writing when the price is what?
When the price is
Okay.
$5.75.
Yeah, that's pretty important.
Agreed. So what do I have so far as my I've named my variables that I would like to use. And so how do I rewrite my equation of proportionality using my updated variables?
Wow, 3 is pretty rare.
Oh, I thought it was 10, Carla. It's not fun.
I mean,
Where does the price go?
I know I was in the presence of an Aura Master.
Where does the demand go?
Demand
X.
is X.
We're going to use x for the variable demand, yes?
X, demand is Y.
Yes.
I just saw this guy.
What's k?
Thanks.
Sorry, I think I left my computer.
We don't know what k is. You can get it.
Come,
We don't know what k is.
come get it.
And then what goes in the denominator?
X. So cool.
No, I'm updating my generic.
P.
Yeah, price is the thing that it varies inversely.
Nice one, bud. What?
You just broke your
that
thing.
shit. You just
Get on the floor.
you may or may not have just
There's
stepped on
glass
glass.
on it.
So there's
Uh-oh.
broken glass over here.
Sorry.
What was it?
What was it?
It's like a
your
solar.
your moon phases picture.
Do you want me to throw this away or?
Put it in your pocket.
No, throw it away.
Sorry.
In the put it in the blue bin.
I'm really sorry.
You're okay.
Does that say $6.4
I broke his big
or
year.
$64?
Here?
625.
Say sorry, Jackson. Say I'm sorry.
He did. Leave him alone. 625 is the first one and 575 is the second one. So I think somebody told me what goes in my denominator here.
P. The price.
P the price.
P the price.
Right. So what can I fill in? What do I know?
I don't like when you don't make it the like first letter of the word.
Like
So you want demand to be over here?
Yeah, no, I feel like because then I'm gonna be like, wait, what's X?
What is that?
But like if it's D, then
You
I'm
know,
like,
actually, this would be a less confusing way to do it, because I already have an X here, and I don't want to introduce unnecessary confusion. So I'm fine with calling D the demand.
yeah, yeah. See,
So what do I have so far?
We like that color.
Me? No, dude, I'm totally in support of that noise.
Eric,
Yeah.
what do I have from my problem? Charlotte and Sydney.
You have D?
Yeah. So what's D? From my my one data point.
5.75.
Nope.
400 units.
400.
Even the 400.
And what's the price at that when that's true?
575
625.
or 625,
Price is X.
and then we want to find 575.
I'm
That would be.
I'm going data mining right now. I'm extracting the example data that is given to me in my problem.
Yeah.
So price is 625. So how do I put those in my equation?
400.
400 equals K over 625. So K equals,
Whatever that is multiplied.
okay? Anybody have a calculator?
2,500.
I don't believe that. Oh wait, my calculator's still here.
Okay, so that would be, so part A is find the equation.
How is this?
Bro.
I'm just crashing out.
What's my equation for relating price and demand?
P equals 2P.
Say it again.
D equals X.
D equals what?
X. Oh wait.
Two
K
solved
over
in
P.
500.
I thought that was an X.
We just spent some time solving for K.
2,500
Oh.
by X.
2,500 over P.
So part B,
Nah.
That is
Yeah,
P?
done like a nice game.
Yeah.
what?
My bad.
That's
What's
okay,
wrong?
I forgive you.
Just
I
investigate.
thought it was X. Okay, that's P.
So we want to
Right.
approximate the demand when price is 575. So this is part B, approximate the demand.
What are all those steps? We should label those steps.
Where? Which ones?
Define P or K.
Oh, so I did the name variables. I updated equation of proportionality.
Is that what the everything below let P be the price or whatever? Okay.
3 was I solved for K. And then I answered A, which is find the equation relating price and demand, and B is find the demand when the price is 575.
Are there gonna be problems like this on homework?
Which one, B?
No, like this entire example problem.
There wasn't one like this one, B.
No, she means set B. I don't know. I don't remember.
Okay.
How do I find the demand when the price is 575?
Just plug it in
Plug it in, plug it in.
and then divide.
D
What?
equals K over what?
X on P.
Plug Warren.
Plug Warren.
Oh. P equals 2,500 over 5,175.
So what's the demand?
Good work,
434.78260887.
Okay, 435. What?
Units. It just said units.
Units, that's my answer.
What do you think they're producing here?
Widgets,
Wait, find what?
gizmos,
Under price? What does B say?
find demand when price is.
Knickknacks?
Yeah, probably knickknacks actually.
Yeah, probably knickknacks.
I'm gonna.
I think it's what's it's actually.
Yeah, sorry.
Where did we get 2,500 from?
It's like What's It's Galore Incorporated.
What are these?
They've got thingamabobs. I've got 20.
Okay, okay. I got it. I got it.
No, they're singing the aerial song, the song from.
K is the K is the constant.
Like who's it and what's it still?
No, it's just the what's it,
He literally was. Okay.
Okay.
Please go back up a little bit.
Combined variations?
Oh my gosh.
No, I'm not ready.
No.
It's gone out of control.
Why do we have to do both?
I thought you said there were only 2.
Two so far.
Yeah.
Carla, we lied so long.
Mr. Shade,
That's not
I'm
good.
like almost halfway through my notebook. Oh wait, no.
You carried that 7 up around, but you haven't like.
It's because it's not very good. I feel bad about it.
You feel
Whose
bad?
was it?
Yeah, Molly's. I stole it from her house.
Can I have it?
You want
Can I
it?
try
Yeah,
it?
I want to try it.
Like,
I want.
well,
I
it's
want to
just-
know why.
Okay, it's just weird because it's zero sugar. Like, it probably would taste good. It's just zero sugar, and so it tastes weird. And like, gooey.
Or, it's like, it's not something I would drink.
Yeah, yeah.
Man, take it, man.
I hope no one in here is mono.
Can you imagine Molly?
I'm so monoed up.
Yeah.
I mean,
It's not like bad. It just tastes weird.
it's not bubbly.
Wait,
It's
yeah,
flat.
it's not.
Well,
It's
that-
not carbonated.
No, it was carbonated,
And then you've been
and
carrying
then
it
I've been
around
carrying
for
it
too
around
long.
for like 3 hours.
Are you gonna drink that?
I don't know, do you want me?
I gotta slam it for the clout.
For What,
Do you
what
want
what's
it?
five, Carla?
You can have it.
I'm gonna ask my friend Cool.
I know, right?
Or, okay, Carla.
Or you
Just,
want?
just text me, sure. Sorry, one. You're good, Carla.
Mr. Shado, you write a lot.
Yeah.
You're welcome.
With like little speaking too.
Yeah.
It's not indirect.
Like you look,
It's
you look away for like
inverse.
3 seconds and you look back and suddenly there's like 5 new pages. Yeah.
It's
I'm literally
combined.
still writing the
It's
A and B.
It's so
Or
combined.
is it indirect now?
No, indirect is nothing.
Then change it to inverse variation.
Oh, sorry. I gotcha.
It took me 2 pages to write that one like example problem.
Indirect?
But-
English math?
Yeah. Like it.
The one we're doing right now.
Really special.
Which one?
What is that?
Yeah. Well, just delete one.
I guess my page is big enough.
Huh, I bet you could have been yours.
Wait, have you talked about
Probably.
Wait,
That's
my
it.
page is bigger than yours?
You need a more advanced sense of humor.
Actually,
That
that's
was
right.
very immature and elementary, and I'm disappointed.
Oh, you want to talk, no? So what about the
Don't,
other
come
one?
on, don't do that.
His form of like being funny is just being racist.
What kind of accusation?
True accusation.
I love all my
She looks like
peoples.
she keep. Why does he have birthday secrets? Like I don't know.
I don't even say
His
his word.
handwriting's really good though. That's his
So who's had
handwriting.
physics? Who's had physics?
Earth, man.
So the volume of a gas varies directly as the temperature.
Wait, a version of the idea.
I'll
Ideal.
do ideal best.
So the volume of an enclosed gas varies directly as the temperature. Temperature goes up, the volume goes up. Temperature goes down, the volume goes down.
I did this in science class. Why would you-
Right. So I'm asking you to remember from your science class that the volume of a gas varies directly as the temperature, and inversely as the what?
Pressure.
Oh.
Oh.
I tried it.
I'm not racist.
Carla, what prompted that?
Because,
I said he was racist.
yeah.
I thought he was just like announcing it.
No,
No,
you're not.
he
racist.
made fun of my sense of humor, and I was like, your sense of humor is just racist, and now he's upset.
I am. That's not cool.
You said that I have middle school.
Why are we
humor.
having this conversation?
Because I'm not racist. I can't have that reputation.
We can't be doing another example problem already.
I don't think you're
Oh,
racist.
but we
He's
can.
racist.
Can you slow down or like
but
talk
I
your way
like
through
that
it?
you're
Or like
actually
if my
doing
humor
more
would.
like actual example problems.
Yeah, this is
So I
great.
feel like it helps me understand what we're doing.
It's respectful. Like if my humor was a person.
The pressure
Okay.
of the gas.
All right,
is-
Carla.
No, I think you.
Okay, Carlo.
Physics question.
Okay,
Okay.
I'm done.
Thank you.
I let it go.
Good.
My charges.
What is example?
This is a lot.
Please slow down.
Ew, kilograms centimeter squared.
E.
Yes, ew. That's not a nice unit.
Are there good E's?
What?
Are there good E's?
No, I said unit. It's not a good
I
unit.
thought you said.
I said U, and then yeah, it's not a good unit. But there are good units that no longer, or like that don't invoke a
What's
U.
a good unit?
I don't know, something that isn't divided by something squared.
I see.
It's just something easier.
Write an equation relating pressure.
Relating.
Mr. Shadle,
Mm.
do you know how to write in calligraphy?
I always do. Everything I do is calligraphy.
I just said rotating.
Oh my god.
Rotate.
I'm
f of g of x. Is our final at the end of this semester cumulative the whole year?
Yeah.
Oh my God.
Sorry. It's over like chapter
That is
1
how
too.
the final works.
We never did chapter 1.
Doesn't. Well, for some classes it's just a semester.
I
Yeah,
feel
the
like-
semester classes are final.
I feel like Mr. Harrison's final last year was just solely based on that one little part we can
No, I don't know
I
what's
blacked out.
happening.
How do I solve this?
The like average grade for that test was like.
Let me finish
50.
writing.
No, it was like low.
When nobody in the class can finish the packet he hands out, you know that there's a problem.
I finished it.
I start crying.
All right, how do I solve
I'm
this?
the only one.
What is?
I had extra time.
I also got a like
Sam.
B, so.
What?
How do I solve
I don't know. I'm still writing combined
What's step one?
variation.
Warren, what's step 1?
You write out the equation.
You're cooked, man.
I can tell. I kind of got that already. Thanks.
Mama.
Oh my gosh, it's in
All
Kelvin.
direct and English variations of number.
So what sort of equation of proportionality can I write for this sort of combined variation where I have both direct and inverse variation?
Can you repeat that question?
So what kind of equation do I want? Do I want an equation that looks like y equals kx, or its close neighbor y equals kx to the n?
What you want is
Well, you,
Y equals k over
equals
x.
K over x to the n. That's what you want.
So up to this point we did direct and inverse as an nth power of x.
Wait, go back. So
This time we're doing something different.
Can you write two different equations and then combine your?
One combined equation.
Do you have to like? Combine
Wait, what
it
are the
and
two
be,
on the
like,
right?
Y equals
These two,
K.
that's the version
and-
of direct variation where the exponent n is not 1. This is the version of inverse variation where the exponent of x is not 1. This is supposed to be an n. So this is these are direct,
Would you
two
see
versions
why
of
my
direct.
teacher yes?
and these are
Slam it.
two versions of inverse. What I would like to do instead is have a one equation that involves both direct and inverse variation.
Can you do like
Go for it.
K times K over X or like something like that? Can you like?
K times k would be just a different constant. I might as well call it k. So k is not going to appear twice. So I need a direct variation and I need an inverse variation in here.
Y
Uh,
over x equals k.
Y equals K over X plus KX
It's not plus.
times
Pa-
KX.
parentheses to the power of n.
I have three different things that are related. So
K over
if I say that the volume is going to be on the left side of the parentheses, and then temperature is going to be where, and pressure is going to be where.
Well, your volume equals Y, and then it doesn't matter for the other ones as long as you associate an X value.
It matters where they go in the fraction.
Oh, the volume.
So
is
let's
gonna be,
step 2 name variables.
I think volume is gonna be X1 because you can do X to the N.
So I'm just going to say let V be volume. And then what's my unit for volume?
Centimeters cubed.
Right.
So our equation is K.
So what else? What other variables can I get? Can I sort of invent from my problem? Warren, give me a variable.
Pressure.
Give me a variable.
P.
Let P be pressure. What's the units?
That's kilograms over centimeters squared.
Sam, give me a variable.
I'm on A, my guy.
Let's think about it.
Where are we at?
I'm making variables for volume, pressure, and what else do I need?
Temp? I don't know, I don't think I
Temperature.
So put T. Like TV temperature.
What's my units?
VPT?
What's my units?
Arlo got it.
Celsius.
Mm-mm.
Kelvin.
Kelvin.
Sorry. I was just looking out.
So let's put that together into make an equation of proportionality.
I think it's next.
Amelia, help me out.
I don't know.
Yeah, you do.
No, we don't.
Something equals something. So my problem says that this ideal gas law says that something equals something. What's the something that it equals? Or what's the something on the left-hand side of the equation?
We want,
You should scroll down.
we want,
Other way.
we want pressure to be what? We want, what?
Because volume is the one that varies.
Is it?
Yeah.
Reread the question.
Volume of an enclosed glass or gas varies directly as the temperature and inversely as the pressure. So V equals,
V equals.
and then X2 is going to be temperature because it directly varies, and so it's not going to be,
Let's not forget about K.
K.
So K is just K is always just in the numerator because it's a constant. If I put it in the denominator, I would just do 1 over and it would still be a constant.
K over P
Yep,
times T.
right. So I got these from volume varies. So I'm gonna put volume on the left hand side of the equation. I always have a constant here. Directly as the temperature, so temperature is the direct part. Temperature is the numerator because it's direct, and then pressure is in the denominator because it's inverse.
I'm so lost.
I miss numbers.
Are you not?
Could you like organize the solution part because everything is in a random spot and I don't know what is where.
You
Yeah.
don't need
I think you need to like you need to make your notes more organized.
You
They
need to,
are
like,
organized. You guys are just
No,
commies.
this is like.
So like
This
This is as good as it gets.
It's right. You
This is
don't
as
need
good as
to
it
write
gets.
the y equals kx. You don't need to write that top stuff in the corner.
huh?
This was just kind of
That
review.
was just review.
All this stuff over to
And
the
then just
side
go down
is just
the
sort of.
list.
We were just reminding ourselves of where we are and what we know how to do so far, because we know that the direct type of variation puts the variable in the numerator, and we know that inverse variation puts the variable in the denominator. So now we're doing a new thing that involves both direct, and we got this from the problem, and indirect. So the problem told us that temperature was a direct type of variation, and that pressure was an inverse type of variation. And so we've just made variables for our volume. That's V. T is for temp. P is for pressure. So What's my next step, Sam? Step 4 is what?
Step 4, solve.
Solve for?
Solve for B.
It's always solve for K.
Solve for K.
Solve for K. So on problems like this pattern is they give us an example where we can say, well, in one circumstance, I know that pressure is this, I know that temperature is this, and I know volume is this. This gives me a way to put numbers in for everything but K, and that allows me to solve for what K is. Just for science fans, if I did not have a K, then the best I could say was volume is proportional to T over P. I can upgrade this from proportionality to equals by including a constant of proportionality. That's K. K is literally called my constant of proportionality.
When you're writing, like, for solving for K, do you want us to write units or just leave it?
So if you're very careful and meticulous, you can use units.
Okay.
If you're trusting everything to the wind that it's going to come out right,
Is this supposed to be a scribble?
you can probably not do it. But your final answer has to include the units.
The V scribble T over P.
Yeah, that's approximate. That's proportional.
I thought it was two. I thought it was split. Or wait, yeah.
Well, because
Well, I'm not saying it's approximately equal. I'm saying it's proportional. So you could write it that way, or you could say proportional.
Because if you write your temperature multiplied by your K and it's in Kelvin, you get K 294K. So
K.
that
We're not saying that units of K are Kelvin.
I know, but like just like okay. Okay.
So let's solve for K. Annabelle, how do I solve for K?
Times P on both sides.
I'm gonna put in values for P first.
Oh.
So I have, the problem is giving me values for everything except K. That's what allows me to solve for K at this point. So how do I do that?
Well, you have your what's it called? Your pressure. So you have to do 0.75.
0.75 as pressure.
Then you don't have your K, but you do have your time, right? So then you have to.
It's not time.
Or not. I mean temperature. Sorry, I don't know why. Which is where is that? K, 294.
294.
And then you just put regular K, and then you solve for it. So you have to.
I'm not ready to solve. I don't have an equation yet.
You have your volume, which is going to be 8,000 centimeters cubed. So you just put 8,000.
8,000.
And then you times the 0.75 on
Right.
both sides.
Right.
And you get 294. I don't have my calculator on me, but.
All right. Somebody with a calculator, let us know what K equals.
6,000.
And then you divide the 6,000 by 294.
What's 0.75 times 8,000 divided by 294? That's going to give us K.
It's 20.40.
20.40.
Well, 0.41 technically.
20.41.
What would the units be?
So the units are going to be some combination of centimeters squared,
So
Kelvin, and cubic centimeters.
No, you gotta do your kilograms.
Oh, kilograms per centimeter squared.
Oh yeah.
Kilograms per
209.
centimeter squared. Kilograms per centimeter squared. So in
kg.
as a science question, they could give you part B is what are the units
Wait. So what was the thing for the 20.41 equals K with units?
That's
of K. So a different constant of proportionality in a different equation is going to have a different combination of units that are all going to be stuck in there. And that looks like that's Kelvin in the numerator, and that's kilograms. So it's gonna be
Boys swim season is
It's gonna be like, well, 'cause if you're
Centimeters.
multiplying centimeters squared.
it's gonna be kilograms, centimeters per Kelvin.
Could you please scroll?
Okay, so that's K. What's our next step?
The units.
So that as a side note, you could be asked to give the units of K, and we would just figure it out from this equation. We're not
So we
gonna
don't need units.
we're not gonna do that right now. Your final answer should include units. Like when we're saying what is the volume, then you should give the units for volume at the
So
end.
could you please write the units right now so that when we look at our notes later we can tell how we got them?
Yes.
This is eerily similar to chemistry.
This is chemistry.
Oh. Well, I mean, like, no, not like that. Like, obviously it is chemistry, but like, in terms of like, Arlo.
What, dude?
I feel like it's like,
I forgot my K.
That wasn't me.
Okay.
Are you guys beefing today?
I didn't know I wasn't trying
she was
to.
making fun of me.
So I have Kelvin and I have a constant K. So I'm going to try to make this obviously a capital K and this obviously a lowercase k. If I multiply both sides by 0.75, I've got 8,000 times 0.75
And this is for
Times.
units, okay?
cubic centimeters times what? Kilograms per
So do the
centimeters squared.
cancel, so you just get centimeter kilograms?
Centimeter kilograms. Yep. So it's going to be centimeter kilograms equals K times 294 Kelvin. Make that a big K. And so when I divide both sides by 294 Kelvin, I'm still going to get 8,000 times 0.75 over 294. And that leaves me with centimeter kilograms per Kelvin.
Is it kilograms over centimeters squared or centimeters cubed?
So here I started off with centimeters cubed, and I multiplied it by kilograms over centimeters squared. So that left kilograms in the numerator and centimeters squared in the denominator, with centimeters cubed in the numerator. So I just 3 minus 2 is 1. So that left me with centimeter kilograms per Kelvin.
My favorite thing is that you do these really hard things and then we all get stressed and then on the test it's like, what?
What's step 5?
There's 30 seconds left.
Step 5 is write your equation of proportionality. Now that we have a K.
Yes.
So what is my equation of proportionality in general?
V
V
equals
equals
20.41.
20.41, came from up here.
Whatever the units are, centimeters.
Time, well, that's okay. We'll just skip it for now.
T
Times T
over V or P.
over P. And if part A said write my equation of proportionality, there you go.
Oh my